We are going to solve trig equations. So just like any algebra equation, we are going to try to isolate our terms with our variables, and then we're going to eventually get to solve for values of that variable. When we're solving trig equations, there are a few considerations that we need to make sure that we cover. We are going to have to take into account the standard period of the trig function we're solving for. So take into account the standard period for the trig function that we're solving for. I'm just going to say for the trig function involved. So for instance, if we're solving for sine, we'll be solving for the variable, but if it involves the sine of x, the cosine of x, the cosecant of x, or the secant of x, that period is 2 pi. If we are solving for a variable involving the tangent of x or the cotangent of x, that period is just pi. Another consideration we need to take into account is trying to isolate the function. So everything that we did in the previous lessons, where we were verifying and simplifying, all of those techniques are going to help us in solving complicated trig equations. After we isolate that function, we're going to be able to solve for the angle. And in most cases, we're going to solve for the angle in radians. So let's give it a try here on this first one. We're going to solve 2 times the sine of x minus 1 equals 0. I'm going to use my highlighter here, and I'm going to highlight the trig function. So what I want to do first is I want to take into account the standard period of that trig function that's involved. So the standard period, I'm just going to jot it down, is 2 pi. Now we're going to come over here and we're going to isolate the trig function. So I have 2 sine of x minus 1 equals 0. I'm going to add 1 to both sides. So now I have 2 times the sine of x equals 1. Then I'm going to divide both sides by 2. I've successfully isolated that trig function. So I have the sine of x is equal to 1/2. Now there's 2 places in that period of 2 pi where the sine of x is equal to 1/2. So I'm just going to draw a quick picture here. We've got pi over 6. That has an ordered pair of square root of 3 over 2 comma 1/2. So the sine value is y. So pi over 6 is one location that gives me a 1/2. And the other angle in radians is 5 pi over 6. Now we know that not only pi over 6 is going to be a solution, but every coterminal angle thereafter. So pi over 6 plus every coterminal angle. Well, every coterminal angle is adding a 2 pi. So I'm going to say 2n pi. Now the n stands for an integer. So I can add 1 revolution, I can add 2 revolutions, I could add 3 revolutions. So a revolution is the 2 pi part. So if n is 1, I would add 1 revolution to pi over 6. If n were 2, I would add 2 revolutions to pi over 6 and land in the same place. See, there's 2 revolutions. I could add 3 revolutions. I could even subtract a revolution. So I could subtract a revolution and still end up in the same exact place. Subtracting a revolution would make n a -1. So that's why we say integer, because integers are whole numbers and they're opposites. So pi over 6 plus 2n pi is one solution. Another solution is going to be 5 pi over 6 and every coterminal angle thereafter. So every 2 pi, that angle will, or that location repeats itself. So that value will repeat itself. So our 2 answers are, I sure as heck didn't leave myself a lot of room here, did I? So let me move this. So our 2 answers are pi over 6 plus 2n pi and 5 pi over 6 plus 2n pi. I'm going to box those. And I'll explain the 2n pi again in the next example. I'm definitely going to have to move to another piece of paper. And I'm just going to do that right now so it doesn't stress me out. So just hit new page and I'm going to hit paste. In fact, I'm going to add both of these to the other page. This way I can take some time to really explain what I'm talking about there with the 2n pi. I don't want you to be confused. Okay, so here we have cosine of x plus the square root of 2 equals negative cosine of x. So what I'm going to do is I'm going to highlight the trig function. Well, the trig function is cosine of x. So I've got a couple of those. The standard period is 2 pi. I'm going to subtract cosine of x from both sides so that I can get those trig functions together on one side of the equation. I've got the square root of 2 equals -2 cosine of x. I'm going to divide both sides by -2. And the cosine of x is equal to negative square root of 2 over 2. Now what we need to do is we need to think about that standard period. So I'm going to come over here and I'm going to draw where cosine of x is equal to negative square root of 2 over 2. So that's, cosine is the x value, and square root of 2 over 2 is a pi over 4. So it happens at 3 pi over 4, right? It's the x value. And it also happens at 5 pi over 4, right? But it happens every 2 pi. So not only at 3 pi over 4, but 2 pi later, and another 2 pi later. So here it could happen twice, right? So I could add 2 pi twice. I could also subtract a 2 pi and still end up in the same exact location. So x is equal to 3 pi over 4 plus 2n pi, and x is equal to 5 pi over 4 plus 2n pi. So there's our answer. So when we're solving for the variable, and that variable is an angle, we have to remember that the sine of x, I'm going to try and do a good job here. The sine of x, I know it's been a couple weeks since we graphed these, but look at that. So that's our sine of x. In fact, I want some more negatives over there. So I'm going to keep going. Let's just say we're talking about the sine of x. Let's come back to this one. The sine of x is equal to 1/2. So 1/2 is right here, right here. So those are our first two. But look, it happens if I subtract 2 pi. So this one is subtracting 2 pi. This angle subtracting 2 pi. It also happens if we add 2 pi. So if I continue this graph, so hopefully this is giving you a nice little visual. And this continues forever, right? So it keeps going and going. So there's those two values, right? That's where, so add 2 pi, add 2 pi, and then we could even add 2 pi again. So we could add 2 pi again and add 2 pi again. And we're going to end up in the same exact location, that same exact output of 1/2. So that's why we have to take that standard period into account, because we're going to be in that same exact y value, that same exact output every 2 pi later. So every horizontal period length will end up in that same exact location. So in the next video, I'm going to do the next 3 problems. A matter of fact, take a look at number 3. I'm going to have you try that, and I'm going to go through that a little bit quickly so that you could just see the answer. And then number 4 and 5, I'm going to actually show you, because those are different type. They have an exponent involved.